Thank you for good introduction. I'm Satoru Oishi from Kobe University, as well as I was formerly team principal of the disaster team in R-CCS. And today I would like to talk about the large-scale disaster simulation. But the first half, we have 45 minutes. I think it is good time for you to consider about the problem of programming. So, I will explain it in the second half, but we need to lead this kind of design draw for simulating the shakes of such kind of bridge piers. Therefore, we need to lead such kind of vector data. They are only vector data, not only vector data, but also they have a very ill-constructed format, like many arrows, many digits, and so on. So I summarized it into a very simple question about it. So could you please solve this problem with generative AI like Gemini or ChatGPT? So please make a program to obtain the lowest coordinate of the rectangle at the top of the arrow, expanding from the word smaller in the attached PDF. The coordinate origin is the intersection of the x-axis and y-axis at the bottom left corner, and the unit length of the coordinate is the length of the x-axis. So it is for generative AI, but actually there is word smaller here, and there is a arrow pointing out this rectangle. So my problem is find out the coordinate at the lower left point. Here, the coordinate origin is here, and the coordinate unit length is length of the x-axis. So that is not much difficult, you may think, but it is somehow, if you try it, it may be you may face some difficulty. The simpler difficulty is the coordinate origin, directions, and coordinate, and the direction of the coordinate and unit length of the coordinate are different from them in the PDF format. So basically, the PDF format, the coordinate origin is top left bottom, top left, left top, and the coordinate unit is something different from this x-axis. Okay, and there are many other rectangles for puzzling it rather than the target. Target is here, but there are many other rectangles for puzzling it. It requires bottom left corner of the rectangle, not the others, and not point in the PD, not the point in the PDF point format. And you have to detect the word smaller rather than bigger rectangle. It is puzzling word. So you have to detect smaller. And the distance between the word smaller and the target rectangle is somehow far from the distance between smaller and the other rectangles that is not a target. So I already set, I think I gave you this lead figure from PDF here. So you can download it to your PC and try it to make a program. So for person who do not have any idea about your programming environment, please use Fugaku with C++. But if you are very good skill in Fugaku, you can do. But if you are somehow beginner of Fugaku, you may have some difficulty. Or please use Google Colab for using Python. Easier to start. That is easier to start. But you may face some difficulty to get accurate answer. So you may have 30 minutes. So please try, and if you get the answer, please show me. Or if you have any question, or if you want to give any suggestion, please let me know. I will give many suggestions. So at the end, this is the result. Sorry. これだね。If you directly ask ChatGPT, I think so, to put my question with the PDF, with this PDF, at that moment the answer was something wrong which we need. So the ChatGPT, or the ChatGPT 5.0 cannot identify the exact problem of it. I may slightly open the problem, the answer. If you are very talented C++ user, you can do it. But most of you, people like me, not much talented, for this kind of problem, you may use the Python is easier, because the Python has modules that read PDF. So if you use C++, you may use some library of reading PDF. There are two main libraries. One is free soft, and the other is licensed soft. And the licensed soft is more accurate, and you want to install it. The name of the licensed soft is PDFuim. That is very difficult to install into Fugaku without big skill. So therefore, I may recommend you to use Python, and you use Python reading PDF, need that pip install PyMU PDF. So that is suggested by also by ChatGPT 5.2. Then, so you may ask, I'm sorry, it's in Japanese, but it's exactly the same as I put on the PDF. Ish. Yeah, this one. So please make a program of this one here. Then it takes 2 minutes to consider the chat PDF. It may 2 minutes to consider. And yeah, actually speaking, I tried several times, like 4 or 5 times to do to reach the exact answer. So this is I'm sorry in in English version. So from here in English version here. So using PyMU PDF and several classes you make or ChatGPT makes, then you can reach out the exact answer. So yeah, I want to give guarantee to the ChatGPT can solve if you give some good suggestions or some good points to ChatGPT. For very beginners, if you use that Google Cloud, oops, what's happening? You may put your data into that folder. So you may place this folder and that kind of section is open. Then you drag and drop your test file into here. Then the Python in Google Cloud can read that PDF by using PDF path, the name, then open, that's it. Okay, so this is 3 o'clock. We will have a break. During break, I will share my code, and so afterwards you can try it. And during breaking time, you may ask me about the problem or some details if you need. So the second half, I will explain about which kind of difficulty they overcome, and I will proceed to the general disaster prevention research works in high performance computing. So please please have your break.
Thank you, Professor.
Yeah, welcome again. So I would like to give some answer about the problem. This is the image that I measured the PDF by using the Illustrator, that is the vector drawing software. if I can point that location, the x-axis of the PDF format is that, y-axis is that. And if I can read this arrow, the unit length, the point out here, such kind of it. So then I can also read the length of it. It is 28 millimeter. Therefore, yeah, by some arithmetics, we can get this one in x-axis of our defined coordinate. 44.7 is the y-axis of our defined coordinate. So that is the correct answer. And I put that data and the code which calculates correctly. If you are not familiar with Google Colab, please follow me. So this is the first image when you use the Google Colab, and then maybe you want to make a new notebook, and you will select file and upload notebook, and drag and drop HPC School 2026.ipynb notebook. Jupyter notebook, you may put it, then you can, yeah, maybe you are doing the same one. It may take a time. Maybe it takes a long time. So for reducing the time consuming, you can watch this kind of one. And so place this mark to run, place this mark to run. Then the answer, in English, the answer is 3.4, 4.7. So in the last part of the program, it can summarize which kind of things they did. First, extract geometry and locate the smaller. So the first thing is to detect smaller, and you can change it into variables, and then you may put any words for target. And detect axis and unit length, and convert origin to bottom left coordinate system, and they find arrow. So the program is somehow making fake to ignore the smaller, to just find out a tip. So if you have two tips of arrow, so there are, if you have two tips of it, it maybe some wrong answer, may give some wrong answer. And then normalize it and give results. So, and then in detail, the functions find axis, origin, and units. So these functions, naming of the function is the same as the naming rule for the masters. Masters mean the good code writers. You can use it for your education as well. So it may take time. So then I stop explaining about it, and it may take 30 minutes for it, but it is too long. So I would like to explain about the necessity things for large-scale disaster simulation. From here, this is a lecture. So in Japan, we have a lot of risk of natural disasters. That is, okay. In 2016, in Kumamoto, in the southern part of Japan, we have severe earthquake, and the Kumamoto castle collapsed partially, and government assumed that it takes 200 years to completely repair. However, if you visit today at Kumamoto, you can see the main building of the castle. So that part is the second largest building of a castle. So the main castle is still you can visit and you can walk inside and so on. So this is mine. I visited last August. As well as 2011 Great Eastern Japan earthquake and tsunami, we call it as GEZ. So it kills more than 18,000 people, and fully damaged houses more than 400,000. So at that moment, tsunami hit the coastal area of the northern part of Japan, and people didn't aware about the height of the tsunami is as high as 20 meters. Therefore, there is a wall preventing tsunami intrusion, but the wall doesn't work well, because the tsunami height is much higher than the previous estimation. Therefore, people escaping by using cars and on foot on the road, they get suffered. In 2018, we had many disasters, and one typhoon brought ships, vessels, moved to hit a bridge. That bridge is connecting the Kansai airport and Honshu. So at that moment, Kansai airport should close for 1 week for repairing the bridge. Insurance payment amount is 7.8 billion at that moment, and maybe it is more than 9 billion US dollar, in terms of US dollar, 9 billion insurance payment. This is 2021 Atami. You may see, now you see a very tragic scenery. That is not a movie, but real disaster. If you feel but please close your eye. Okay, okay. I see. So it was flash flood, and a village or a town consisting of the more than 200 houses suffered from the flash flood, and 28 people killed, 2 people still missing. It more than 5 years, and fully damaged house is 136. So more than 60% of houses are fully damaged by torrential rain. So we have a lot of risk of natural disasters, and this is the world risk index. I cannot see where the point are. Okay. The first one is, the first means the worst. I'm sorry to say. The first one is Philippines. If you come from Philippines, please raise your hand. Yeah, I'm sorry. The second one is India. If you come from India, please. Okay. And Indonesia, yeah. Colombia, yeah. Mexico, Myanmar, Mozambique, China. If you come from China, no. Okay. So these are the world risk indexes. In 2022, Japan was 28th. Before 2020, Japan was the third, but now it is, at that moment it was 22. In terms of the exposure, that is the how frequent and how big damage natural hazard is, the worst country is China. China is big country and many disasters. The second worst is Mexico. And Japan is the third worst in terms of the severeness of the natural disaster itself. But the Japanese vulnerability, the resilient, is somehow better. So we are 6.64 in 2022. Therefore, our total score is somehow lower than the severeness of the natural disaster itself. And yeah, Somalia, the vulnerability is 73. That is the worst country in the world in 2022. Are you come from Somalia? No one? In Kobe University, we have one Somalian guy for disaster prevention, studying the disaster prevention. So, but now we increase the score. It means worsen the preparedness of the natural disaster. In Japan, Japan was 17th in 2025. Yeah, the first 10 is almost same. Philippines, India, Indonesia, Colombia, Mexico, Myanmar, Mozambique, and Russia, China, Pakistan, something. So we are focusing on Japanese one. Our exposure is the same as the previous, but our vulnerability become worse. Then lack of adaptive capacities become worse from 2022 to 2025. What happened during these days? We had Noto earthquake on January 1st, 2024. That earthquake hit the Noto Peninsula that is located in the northern part of Japan. Now we are here in Kobe. So Noto is that peninsula. It's, I guess that the third popular must-visit place is Kanazawa, I think. Yeah, that is the third popular location you must visit in Japan. So Noto is northern part of northern part of Kanazawa here. So this is a peninsula, and it is some difficulty to recover the disaster. Actually, in Japan, when we have earthquake, we almost must have fire. So that fire burnt out all the city of Noto. We also have the cliff failure by earthquake. So the cliff failure buried the tunnel on the roads. And the road itself had a leaky affection. It's unstably waving because of the ground becomes water by groundwater. So such kind of situation happened in January 1st. When we watch TV, because the January 1st is our special day for the beginning of the year, most people have holidays and watch TVs in the evening and waiting for some music, TV programs and so on. But the TV program suddenly changed. The earthquake happened in Noto and very big, and fire happened and so on. It was scary. But the real scariness is the following. In September 2024, torrential rain took place in Noto, the same place as the earthquake. So this is a shelter. People who evacuated from their own house, most of them are burned or most of them are fallen. So the shelter was inundated because of the torrential rain in September. And this house lost their foundation and almost falling into the river, like that. So the World United Nations Office of Coordination of Humanitarian Affairs, OCHA, take these things heavier because our repairing ability is not much as we expected. Therefore, we are getting worse in the score, and people suffer from both earthquakes and typhoon. And at that moment, slope failure took place by the earthquake, and it deposited the sediment. Then it was brought by the torrential rain into rivers, rivers are here, resulting extended flood area. So the earthquake remained the deposit of the sediments, and that sediment go into the river, and the river is buried by the sediment. So the water cannot went through the rivers, and it's overtopped to inundate residents and paddy fields. So we need to calculate such kind of things. And OCHA is also saying the digital technologies in disaster management. They say satellite data is necessary, big data and artificial intelligence is necessary, and so on. But we have to think how frequent we face the disaster. This is a photo in 1995, Kobe, in January 17th, 1995. We had a big earthquake in Kobe, and that earthquake fallen the highway for more than 1 kilometer. And many people, more than 6,000 people killed by earthquake and following fires. But this is the 31st years after 1995. During these first 30 years, we do not have any earthquake-related disaster in Kobe. So nothing. So people changing, disaster didn't happen, so the memory becomes less. So in terms of the disaster, we do not have any experience during our lives. So therefore, I would like to say that the simulation is necessary for understanding the earthquake. So this is one thing, one role-playing game to understand the necessity of the simulation. So this is Kobe port. We are, here, I would like to show the whole image by Google Map. Now we are here in Kobe. This is Awajishima. And here is Osaka. Kansai Airport is here. So maybe get closer. We are now in here. So the southern part of the Port Island. My slide is focusing on this area. So previously we used that port for vessel shipping and so on. But the size of the port is not modernized well. Therefore, we built Port Island and use bigger port. So that port area changed the role from shipping to amusement. So now here is a leisure, almost leisure land, and some leisure vessels, leisure boat and ocean cruise are using this port. So that is this one. So next one is just a simulation. You don't need to get scared. So now Kobe City is surrounded by high tide barrier. Therefore, Kobe City is somehow safer than this simulation. This simulation is under assumption of no high tide barrier. Therefore, the tsunami get intrude into the city when Nankai Trough earthquake happened. Does it work? Yes. So, yeah, if the tsunami happens, almost southern part of the JR line is hit by tsunami. This is JR line you may use. So the southern part, the ocean side of the after the JR line is inundated by the tsunami when no barrier found at all. So please assume that you are here for working. Here means this one. So this is close to the tariff office of Kobe. So if you are working as an officer of tariff of Kobe and locating here, so most of the time you may use a JR station for your commute, 20 minutes walk normally. So therefore, if earthquake hits, the typhoon hits, then you may think tsunami comes within 1 hour. I skipped the important point. Here is time after the earthquake. So 19 minutes. The tsunami comes to the Kobe city, so not before that. Therefore, you have 90 minutes for evacuating from your office to station, closest train station. So you may assume that you have enough time for reaching the train and you go back to your home without any problem. 20 minutes walk, but many people head for some station, for the same station. So people are get close. Then such things happens. After the earthquake, all the train stopped operation for almost 1 day. So you cannot use trains at all for evacuating. But people didn't identify it, so they come together to the station. Then the station get crowd. Not only the station, but the pedestrian becomes crowd. This is not a fake, but it is real one when magnitude 6.1, which is much less than the expecting Nankai Trough earthquake, hit the Osaka at the normal day. So people get crowded. No one can move. That pedestrian is almost jammed. Therefore, that officer has to take zigzag road to people walk through the small passage between buildings. Then tsunami attacks. That is a nightmare. So, but the simulation can aware you about this kind of situation. Situation under disaster is very complex. So, but this simulation recommends you to take this road than normally using road.